Okay, good afternoon, all of you. And as I told you yesterday, we will be revising matrices and determinants primarily today. And again, we have a deadline of 3:15, 3:30. And as much as I can, we will revise determinants, matrices, and I will also try to do a few questions of trigonometry, especially the ones, the kind of questions which have appeared in your exams, in the IPMAT exams in the last few years. So just stay with me till the end of this session. We are going to solve some amazing questions, very similar to and of the same difficulty level as have appeared in IPMAT 2022 IIM Indore exams. Since this is a revision session, I will be covering almost all the important properties of matrices and determinants in addition to solving questions. And be with me till the end, very end of this session, and you should gain from this session. This will matrices and determinants is one topic from which you have one question almost every year in IPMAT IIM Indore exam. So let us get started. So what is a matrix? Matrix is an arrangement of numbers in rows and columns. So you arrange numbers in this fashion: A, B, C, D, E, F, and put a square bracket around it. And this becomes a matrix. So you're arranging them into rows and columns. And order or size of matrix is determined by the number of rows and number of columns. Generally, you represent a matrix by rows by columns. So in this case, there are 2 rows and 3 columns. So this is row 1, this is row 2, this is column 1, column 2, and column 3. So remember, if you represent a matrix by R by C, each of this A, B, C, D is called as an element, and number of elements in a matrix is determined by R cross C. So if it's a 2 by 3 matrix, the number of elements will be 6. If it's a 3 by 4 matrix, the number of elements will be 12. So each matrix has a determinant, and the determinants have scalar values, and determinants are always made up of square, only square matrices will have determinants. So when we say determinant, then there is no R by C, it is N by N, because the number of rows and number of columns has to be same. Only then we can evaluate the determinant. There are types of matrix which I'll quickly go through. Null matrix, where all elements are 0. Vertical matrix is like this, where there's only one column, A, B, C. This is a vertical matrix. So remember, in vertical matrix, the number of rows will be greater than number of columns. This is basically a column matrix, which is a type of vertical matrix only. A matrix is called a row matrix if it has one row. So A, B, C, this is a row matrix, and this is a row matrix, and A, B, C, this is a column matrix. Square matrix has the same number of rows and columns, and there are 2 important types of square matrices: diagonal and triangular. So triangular matrix can be upper triangular or lower triangular. In upper triangular matrix, all elements below the main diagonal. You would appreciate this is a 3 by 3 square matrix, D, E, F, G, H, I. Now these elements are known as diagonal elements. In an upper triangular matrix, the elements below the diagonal will all be 0. In an upper triangular matrix, the elements below the major diagonal will be 0. So these elements, if they are 0, this will be an upper triangular matrix. Whereas in a lower triangular matrix, A, C, and I, you have D, G, H. all elements above the diagonal as 0. Now this is a lower triangular matrix, right? Identity matrix, a square matrix in which all diagonal elements are 1 is an identity matrix. Diagonal matrix can be scalar and unit matrix. In diagonal matrix, the diagonal elements have the same value. In unit matrix, the diagonal elements have the same value equal to 1. And all the non-diagonal elements in a diagonal matrix must be 0. Remember, two matrices are said to be equal if they are of the same order and each element of A is equal to each element of B. So if I have two matrices A, B, C, D, E, F, which is equal to P, Q, R, S, T, V, these two matrices are equal if they have the same order, which in this case they do have. And now the corresponding elements also should be equal. Only then the matrix will be equal. Next, let us solve the first question for today. And I won't give you a lot of time to solve this question. Attempt this particular question, please. You have 30 seconds to attempt this. Now, those of you who are here for the first time, those of you who are here for the first time on YouTube. Okay, I can see some people on YouTube. So you have precisely 30 seconds to answer that question. Okay, so number of all possible matrices of order 2 and 3, 2 by 3. The first thing is, let us create a matrix of order 2 by 3. I'll call this A11, A12, A13, A21, A22, A23. So you all know this is a standard way of representing elements in a matrix. A11 represents first row, first column. A21 means second row, first column. Now there are 6 elements and each element can have only 2 possibilities. So if each element can have only 2 possibilities, I can select this element in 2 ways, the second element in 2 ways, the third element also in 2 ways, and so on. I can select all the 6 elements in 2 ways each. Therefore, the total number of ways is 2 to the power 6. And therefore, the total number of matrices also will be 2 to the power 6, which is equal to 64. So this is a test of your basic knowledge of matrix and basic knowledge of fundamental principle of counting, which we did towards the end of yesterday. Okay, solve this one. Again, we have, just a moment. Yeah. 30 seconds, try to solve the question. For those of you who are viewing this on YouTube, this is a revision session for IPMAT 2022. We are covering determinants and matrices largely. Every year there is one question on determinants and matrices. Stay with me till the end of this session and we will cover all the major properties of determinants and we will cover a couple of important questions on trigonometry as well. Okay, so somebody has said 6. So if matrix has 20 elements, so obviously row into column must be equal to 20. So essentially this problem reduces to the number of ways in which I can break 20 into a product of 2 factors. So 1 by 20, 20 by 1, correct? 2 by 10, 10 by 2, 4 by 5, 5 by 4. So these are the 6 possible ways in which I can write a matrix which has 20 elements. So the number of matrices will be 6. which should be your answer. Okay. Now, some more properties which you should just quickly revise. Addition of two matrices is possible if and only if the order of two matrices is same. Multiplication of matrices is possible if and only if the number of columns of the first matrix is equal to number of rows of the second matrix. So if it is R by C, then the second matrix must be C by P. Only if the columns of the first matrix is equal to the rows of the second matrix multiplication is possible, and the resultant matrix will have R by P as the order. For example, if I have one matrix whose order is 2 by 5, now in order for multiplication to be possible, the second matrix must have 5 rows, and it can have any number of columns. So 5 by 3. So the columns of first is equal to rows of the second. The resultant matrix will have an order 2 by 3, the remaining elements. Okay. Multiplication of matrix by a scalar A. If a matrix is multiplied by a scalar K, then the new matrix is K times A. So every element needs to be multiplied. For example, if we have a 2 by 3 matrix, so A, B, C, D, E, F, and I multiply this by K, then multiplication is K times A, K times B, K times C, K times D, K times E, and K times F. Remember, this is what happens in a matrix. In a determinant, suppose this were a determinant. Suppose this were a 2 by 2 determinant, and I multiply by a scalar. Now, either I will multiply the scalar into any one row or any one column. Please remember this, very important. Matrix, scalar multiplication means you multiply each and every element. But in case of a determinant, you multiply only one row or one column. And you can select, you can choose the row to multiply, right? If A and B are two matrices, then A and B, if A and B is defined, then it is not necessary that BA is also defined. And if AB and BA are both defined, it is not necessary that AB is equal to BA. There are a lot of ifs. A, this is not A to the power T, but it is transpose of A. So what is the meaning of transpose of A? So for any matrix, if I write the matrix like this, A11, A12, A13, A21, A22, A23, A31, A32, A33. If you write a matrix in this fashion, the transpose is just convert this column into the row. So you write columns as rows. So A11, A21, A31, A12, A22, A32, A13, A23, and A33. So this is A and this is A transpose. So remember, the transpose of A transpose will give me A again, as is written here. Similarly, A plus B transpose is A transpose plus B transpose, and AB, the product of A and B transpose, is B transpose into A transpose. The order here is reversed. Please note down these properties carefully and commit them to your memory. There are some interesting questions which we'll solve based on those properties. Then row operations. So whenever you add or subtract multiples of row or columns to another row or another column, the value of matrix remains unchanged. For example, if I have a 3 by 3 matrix, right? A, B, C, D, E, F, G, H, I. Now suppose I perform an operation where R1 is equal to R1 plus R2. That means I replace row 1 by the sum of row 1 plus row 2. So instead of A, I will write A plus D. Instead of B, I will write B plus E. Instead of C, I will write C plus F, and the rest of it remains same. This is a row operation. So when I perform row operation, the value of matrix remains unchanged. There is no change in the value, right? Or there is no change in the determinant value of matrix. But if two rows are interchanged, suppose I interchange these two rows and I say D, E, F, A, B, C, and G, H, I. This is a new matrix B. So the determinant of B will be negative of determinant of A, assuming this is matrix A. So if you change one row, if you interchange one row, the determinant of the new matrix will be negative of the determinant of old matrix. Similarly, if you exchange two columns, the value of determinant of the new matrix will be negative of the determinant of the older matrix. This is something which you need to remember. इसके ऊपर बहुत सारे interesting questions आते हैं. Now try to solve these questions. Try to solve this question, and I know you need a minute to solve this. So I'll give you a minute to solve this question. Try solving. It's an interesting question. And we have very quickly revised all the important properties of matrices. Those of you who are watching this, viewing this on YouTube, if you're here for the first time, give me a like, please. एक like बनता है भाई, अगर अच्छा लगता है तो. Okay, so anybody who's got an answer? So here we are told that the determinant is singular, the matrix is singular, and matrix is singular is nothing but another way of saying that the value of determinant of this matrix is 0. So if I try to solve the question in the original form, it will be really very difficult for me. Why? Because basically we it's going to result into a complex multiplication. So what I am going to do is we are going to look at some row operations here, and row operations will help us find out the value of this determinant not only faster, but it will also ensure that we don't have to perform so many calculations. So what do we do first of all? The first thing we do is we do R1 minus R2. So instead of R1, I will write R1 minus R2. जिन्होंने कभी किया नहीं, ऐसा होना तो नहीं चाहिए. अगर आप इसे देख रहे हो तो मुझे पक्का मालूम है कि आप पहली बार तो इस तरह के क्वेश्चंस नहीं कर रहे हो. पर अगर पहली बार भी कर रहे हो तो एक बार दो बार देखोगे इसी सेशन को रिपीट करके तो ये समझ में आ जाएगा. बहुत आसान है. So 3 minus 3 becomes 0. X minus 1 minus 1 becomes X, and 2 minus X minus 2 becomes minus of X. The rest of the matrix will remain the same. Now, what kind of operations can we do now? Is there any other operation that we can think of for now? Yes, we can do R3 minus R2. We can replace R3 by R3 minus R2. Yeah, so let us do exactly that. So R3 is equal to R3 minus R2. And now what will this determinant become? The first row will be unchanged, 0x minus x. What will happen to the second row? Since we have to change R3, the second row also remains unchanged, -1 and x plus 2. Now x plus 3 minus 3 will give me x here. -1 minus of -1 will give me a 0 here. 2 minus x minus 2 will give me a minus x there, right? Now we have no choice but to open this particular determinant, find the determinant over here. And how do you find the determinant? I hope you all remember how to find the determinant. A, B, C, D, E, F, G, H, I. So what do? Minus of B into the minor corresponding to B plus C into the minor corresponding C. So what do? Minus of B into what is the minor? D, G, F, and I. D, G, F, and I plus C multiplied by D, E, G, H. So all I need to do is this operation on this matrix. So what should I do? Minus x, and let me put a line there so that there is some distinction. Minus x, and I'll straight away multiply 3 into minus x gives me minus 3x minus x into x plus 2. This is the first part. And minus x, 3 into 0 is 0. And minus of minus x will be plus of x. So what do you get? 3x square minus plus, so plus x square into x plus 2 and minus x square. So what do you get? You get 2x square plus x square into x plus 2 is equal to 0. Take x square common. What do you get? X square into x plus 4 is equal to 0. Now either x square is equal to 0, which means x must be 0, or x plus 4 is equal to 0, which means x is equal to minus 4. So there are two possible values. Now this question can be asked in 2 or 3 different ways. They can ask you how many values of x will make this matrix singular, one way. And they can ask you how many values of x less than equal to 0 or less than 0, which will make this matrix singular. So in each of these cases, you will have to very carefully read the question. Mind you, the IPMAT exam per se might not be so difficult. You should have a habit of reading the question very carefully. If you read the question carefully, you will not make mistakes. And this is a very good question based on row operations, which you could. Now, let us look at another kind of question. Now, this is simple. The question is, which of the following multiplications are possible? Is AB possible? For multiplication to be possible, you know that columns of first must be equal to rows of second. That's the rule. That's the plain simple rule. So what do? Columns of first. So for AB, 3 by 4 is A. And what about B? B is 3 by 3. Now these are not equal. So this multiplication is not possible. Correct? What about AC? AC is 3 by 4 and C is 2 by 3. The columns of A is not equal to rows of C. AC is also not possible. What about AD? Is AD possible? A is 3 by 4 and D is 4 by 2. Now you do have columns of the first, A is equal to rows of the second. So this multiplication is possible. And the multiplication will give out a matrix of order 3 by 2. Now, can you tell me out of D, E, F, anybody who can tell me in 1 minute, why 1 minute, even less than 1 minute, in 30 seconds, which of the multiplications in D, E, F is possible? In fact, in 20 seconds only. Can somebody tell me out of D, E, F, which multiplications are possible? Anybody who can tell me? Okay. So DE is not possible. DF is possible because D is 4 by 2 and F is 2 by 4. So the product will be a 4 by 4 matrix. Similarly, EF is also possible because E is 1 by 2 and F is 2 by 4. So the product will be a 1 by 4 matrix. I hope it is very clear. So if you're clear, try solving this question. You have 1 minute. Try solving this question. Okay. Anybody who got an answer to this? Anybody who got an answer to this? No one? Okay, let us solve it. See, the first thing we need to do is we have to multiply these two. How do you multiply? So column multiplies with the row. So 2x into 1, 2x, and 3 3s are 9. Correct? And then you multiply this with the second column. 2x into minus 2 is minus 4x and minus 12. This needs to be multiplied with x, which is equal to 0. So 2x plus 9 into x will be 2x square plus 9x, and minus 32x minus 96. Both of them must be 0. Correct? So now what? Each of these elements must be 0. So 2x square must be equal to 9x, right? 2x square must be equal to, or let us say, x into 2x minus 9 is equal to 0. X is equal to 0. Have you understood this? See, the meaning of 0 is this whole thing is 0, right? So what are the possible values? The possible values are there. You are getting multiple values here actually. X is equal to 0, 9 by 2, and from the element below you are getting x is equal to minus 32. Have I made a mistake anywhere in calculation? Somebody just check please if I made a mistake anywhere. Oh wait, we have made a. Okay, the question is the determinant of this product is 0, which means 2x plus 9 into x, right? Have I made a mistake in this multiplication? Let me just check that also. No. So 2x plus 3 is the first element, and 3 3s are 9. So 2x plus 12 is the first element, and second element is minus 4x minus 12. And now you have to multiply this, and what do you get? Two x plus 12 into x plus 8 into minus 4x. Okay, I have made a mistake. Just 1 minute. So if I multiply 2x here, I'll get 2x plus 9, and 2x into minus 2 will give me minus 4x and minus 12. This multiplied by x comma 8 should give me a 0. Now what do? You multiply 2x plus 9 by x. So 2x plus 9 into x and minus 4x plus 12 into 8. This must be equal to 0. So can we take anything common here? No, I'll have to multiply 2x square plus 9x minus 32x minus 96 is equal to 0. So minus 32x plus 9x, so 2x square minus 23x, and you have minus 96 is equal to 0. And now you can solve this quadratic equation by minus b plus minus under root of b square minus 4ac upon 2a, right? By putting x is equal to 0, I think these answers are incorrect for the given question. You will get some other answer. So, there will be some other answer here. You have to solve this equation. 529 minus 4ac, 4 into 2 into minus 96. So it will be slightly tedious to answer, but then you will get the value of x if you multiply. Let us move on to the next question. Try the method is okay. The only thing is this answer is incorrect, or probably I copied down the question wrong from the source. Let us move on to the next question. In fact, let us move on to this question. Matrices and determinants, you have to be very careful with the calculations. If you make one mistake and you'll have to do everything all over again. Okay, let's quickly multiply, because ultimately I have to multiply these two and equate with this. So first column with rows. So what do we get? 3y minus 2x, and then you get 3y minus 2x, right? Here you get 3y and here also you will get 3y and 2y plus 4x, 2y plus 4x. Now, if this is equal to 3, 3, 3y, 3y, and 10, 10, which means there are two equations, simultaneous equation. The first one is 3y minus 2x must be equal to 3. The second one is 2y plus 4x equals to 10. How to solve? Just multiply the first one by 2. 6y minus 4x is equal to 6. Add up these two. You get 8y is equal to 16. And we've quickly got the value of y as 2. So y is equal to 2. If you put y is equal to 2 in any one of the equations, 3 into 2, I put it in the first equation, minus 2x is equal to 3. So minus 2x is equal to 3 minus 6, that is minus 3. X is equal to 3 by 2. So there are two possible values, x is 3 by 2 and y is equal to 2. So for this, the two matrices are equal. Now let us solve another question. Yeah, try solving it. I can't give you more than 1 minute, please. And try not to expand. Try to do some row operations first. Whenever you get a question on matrix and you have to find the determinant, try to do some row operations before you actually open up. Okay. So anybody who was able to solve on YouTube also, I can't find any answers. No. Okay. So can we do some row operations? The first row operation I will do is R1 minus R2. See, as a rule, you should remember that you should try to get in one row, in the first row, either try to get two zeros or three elements should be same or one. You could just have the three elements as one. This will help you evaluate the determinant very fast. So what will we do? To make first element 0, this 3 0, I can just subtract row 1 minus row 2 and replace row 1 with row 1 minus row 2. So 3, the second row will be intact, minus 1, x plus 2. Because there are no row operations on row 3, this will also remain intact. Now row 1 minus row 2, 3 minus 3 gives you 0. I've got 1 0. X minus 1, minus of minus 1 will give me x itself. And 2 minus x minus 2 will give me minus x. So I have got one element as 0. Anything else that I can do? Any other element I can get to as 0? Any other element which I can get to as 0?
So row 2 and row 3 operations, so minus 1 can become 0.
Okay, so if I do row 2 minus row 3 and replace row 3 by row 2 minus row 3, my first two rows will not change. Minus 1, x plus 2, x plus 3. Okay, row 3 by row 3 minus row 2. X plus 3 minus 3 will give me x. Minus 1 minus of minus 1 will give me 0. And 2 minus x minus 2 will give me minus of x. Yeah. Anything else that we can do to get another 0 here? By row operations, I doubt. No. So let us now open. So minus x into the determinant, into the minor, 3x plus 2, x and minus x. And again, this is a minus x into the minor of minus x, 3 minus 1, x and 0. This should be equal to 0. What do you get here? 3 minus x into minus 3x minus x square minus 2x. And here you get minus of minus x is plus x is equal to 0. So what do you get now? 3x square plus x cube minus x square is equal to 0. So 5x square minus x square is 4x square. So x cube plus 4x square is equal to 0. I take x square as common. I'll get x plus 4. So either x is equal to 0 or minus 4 will give me the same answer. Next. Okay. Try solving this. Very quickly try solving this. 1 minute. Please hurry up because I won't be able to give you a lot of time. We need to finish a lot of good questions. This question is pretty simple. Okay, what do you get here? Just multiply the scalar with all the elements. This is a scalar. So 2x square, you will multiply it like a scalar 3x, x square plus 8, 5x, 4 and 4x. This must be equal to multiply 2 inside with all 2x square plus 16, 24 into 2, 48, 10 into 2, 20 and 6x into 2, 12x. Now just add up the corresponding elements. What do you get? 2x square plus 8. Here you have 7x. Then here you have 3x plus 4. And here you have x square plus 4x, which is equal to 2x square plus 16, 48, 20 and 12x. Obviously, one of the values of x for which this is equal. In fact, there is no value of x for which this is equal. I guess something is wrong with this question. We'll just leave this question. It's anyways an elementary question. All you had to do is just equate the corresponding terms. I think there was something wrong in the question. Let us try this question. This is an interesting question. And this is a beautiful question also. Now, this question is around the same LOD as the IPMAT subjective, integer entry question, integer questions. This particular question is of the same level of difficulty as the integer questions. Okay. So now look at this particular question. AB is equal to B. This is given to you. So this is B, and the elements of B are not 0, 0. That's another thing that is given to you. And another fact that is given to you is A plus D is equal to 10. So you can take any random values of A and D. You can take 6 and 4. I prefer to take A and D as 10, 0, right? Because A plus D is 10. So I can take any random values of A and D such that A plus D becomes 10. So instead of ABCD now, A can be replaced by 10, B, C, and D is replaced by 0. You multiply this with the matrix XY, and you will get the same matrix XY, right? And you're required to find the value of ADBC. Now, what does that mean? 10x. Okay. Now, AD minus BC is basically the determinant, right? It is basically the determinant. So what is the determinant of A? I have taken as 10, B, C, and 0. If I take the determinant, I will get minus BC. So essentially, AD minus BC is nothing but the determinant of A. Now, if I multiply this, what do I get? 10x plus by, and here I'll get cx plus 0y is equal to x comma y. So I'll get two equations, 10x plus by is equal to x and cx is equal to y. I'll put the value of y from cx in 1, right? Put the value of y from 2 in 1. What do I get? I just rewrite 10x plus b. Instead of y, I can write cx is equal to x. Now this x will cancel. So I'll get 10 plus bc is equal to 1, which means bc is equal to minus 9. Correct? And I required the value of AD minus BC, and AD minus BC is basically equal to minus of BC. So minus of BC is equal to plus 9, which should be my answer. It's a beautiful question. And if you try to solve it algebraically, it will take a very, very long time. So such questions you can always solve by assuming certain values for A and B, 6, 4, 8, 2, 10, 0. 10, 0 से काम बहुत आसान हो जाता है आपका. इसीलिए 10, 0 लेके. Next, solve this one. Okay, this question merits 2 minutes. Let's see if you can approach this question in 2 minutes. Anyone who is able to solve this? Anyone on YouTube who is able to solve this question? It's a beautiful question around the same level of difficulty as the actual IPMAT questions. So if you're appearing for IPMAT of IIM Indore, try solving this question. चलो, एनीवन हु सॉल्व दिस? अब देखो, जितने लोग भी इस क्वेश्चन को देख रहे हो, एक बात दिमाग में हैमर कर लो कि जब भी इस तरह का कोई सीरीज वाला क्वेश्चन है, ऑब्वियसली इतने सारे मल्टीप्लिकेशन तो नहीं करवाना चाहता कोई भी एग्जामिनर आपसे, तो कुछ ना कुछ और है यहाँ पे। और जनरली इस तरह के टर्म्स में, इस तरह के क्वेश्चन में, यू विल ऑफन फाइंड पैटर्न्स, whether you're dealing in matrices, whether you're dealing in number theory, whether you're dealing in permutation combination. If there are too many repetitive operations in one question, it means the examiner wants you to find a pattern. Please remember this. So is there a pattern? Let me first multiply the first two terms and see what happens. So 1 ones are 1 and 1 zeros are 0. So this element remains 1. What about this element? 1 twos are 2 plus 1 3. This element becomes 3. 0 into 1, 1 into 0. This element remains a 0. 0 into 2 is 0. 1 into 1 is 1. So you see that 101 has retained. The only element that has changed is this. It is giving me a clue, but it is still not answering my question because I have to do the same operation n minus 1 times. So let me see, let me multiply one more time. So I multiply with the next matrix. What do I get? 1 and 3 zeros are 0, 1. 1 threes are 3. You get a 6. You get a 0 here. You get a 1 here. Again, element 1, 0 and 1. There is no change to these elements. The elements that I am underlining. There is no change. The only element that is changing is A12. I'm sorry. क्या हुआ था इसमें? जब हमने 2 को मल्टीप्लाई किया तो यहाँ पे 3 हो गया. 1 + 2 3 देता है. जब हमने तीसरा मल्टीप्लाई किया तो यहाँ पे 6 हो गया. 1 + 2. See, 1 + 2 + 3 gives me a 6. हाँ, अब मुझे पैटर्न समझ में आ रहा है कुछ कुछ. एक बार और मल्टीप्लाई करके देख लो बिकॉज दिस मल्टीप्लिकेशन इज नॉट रियली वेरी टीडियस. एक बार और मल्टीप्लाई करके देख लो क्योंकि यहाँ पे होना चाहिए 4, 0 and 1. So when you multiply, आपके अंदाज से यहाँ पे इस जगह वाली चीज 10 हो जानी चाहिए और बाकी सब वही का वही रहेगा. So let's see. This is 1. Yes, this is 1. Then 1 4s are 4, 6. This is 10. This is still 0 and this is still 1. So obviously the only element that is changing is this with every multiplication. So this element is nothing but a sum total of 1 + 2 + 3 and so on till n minus 1. So that is precisely what I will do. 1 + 2 + 3 and so on till n minus 1 should give me a 120. And what is this? There is a standard formula. N minus 1 into n by 2, the sum. So n minus 1 into n divided by 2 is 120. इस 2 को ऊपर मल्टीप्लाई कर दो तो 240. अब ये देखते ही मुझे पता है 16 into 15. So n must be 16. मैं इस क्वाड्रेटिक इक्वेशन को सॉल्व भी करने नहीं जाऊंगा. I know that 240 is a multiple of 16. 16 15s are. So n is 16, n minus 1 must be 15. So for what value of n? N must be 16. It's a fantastic question. I hope you have followed this question. Try solving the same question because this question also applies the same basic funda. Those of you who are here for the first time, we are solving questions which are similar to questions that have appeared in IPMAT 2020. Earlier IPMAT exams, especially IPMAT conducted by IIM Indore, and we are solving questions of similar level of difficulty as the subjective questions of IPMAT conducted by IIM Indore. So if you are appearing for the same, please stay with me till the end of this session. We will solve certain very relevant questions related to IPMAT 2022. Haji, anyone on YouTube? Okay, somebody is asking me for HSEE के लिए भी क्लास होगी क्या? जी हाँ होगी. HSEE के लिए क्लासेस हम लोग 7 तारीख के बाद लगाएंगे, 7th of July के बाद. We will have revision classes for HSEE as well after 7th of July. Okay. अगेन यहाँ पे p to the power 40 दिख रहा है, मतलब p into p into p into p कितने टाइम्स? 40 टाइम्स. और थोड़ी देर पहले मैंने बताया था that whenever there is some repetitive operation to be performed multiple times, the examiner wants you to find some pattern. Let us see if there is any pattern. Let's try to calculate p square first. 1 0 1 by 2 and 1. If you multiply, what do you get? 1 ones are 1 0. So this element is 1. Then 1 zeros are 0. 0 into 1 is 0. This element remains the same. Then half into 1 gives you half, and 1 into half gives you another half. So this gives you 1. Half into 0 is 0, and 1 into 1 is 1. So you can see that the only element that changes is this one. So p square, this element is 1. Let us see what will be the element for p cube. I will write down p square as it is because p cube will be p square into p. And then I will write down p as it is 0 and 1. If you multiply 1 into 1, 0 into half, this element remains 1. 1 into 0, 0, 0 into 1, 0, this element remains 0. 1 ones are 1, 1 into half is half. 1 plus half will give me 3 by 2, and 1 zeros are 0, 1 ones are 1. So P3, this element becomes 3 by 2. कुछ समझ में आ रहा है अभी. Can anybody guess the pattern? क्या कोई पैटर्न गेस कर सकता है यहाँ पे? देखो, जब p था p to the power 1, तो ये एलिमेंट हाफ है, 1 का आधा. जब p स्क्वायर है तो ये वाला जो एलिमेंट है a21 वाला, ये 1 है. जब p क्यूब है तो ये वाला एलिमेंट 3 by 2 है. तो ऑब्वियसली जब pn होगा तो ये वाला एलिमेंट n by 2 होना चाहिए. That is the pattern. And to test this theory, you just multiply another time. So we do p to the power 4, which is equal to 1, 0, 3 by 2, 1, 1, 0, 1 by 2, and 1. 1 ones are 1 and half. So this is 1. 1 zeros are 0. This remains 0. अब एक चीज तो पता है कि ये तीन एलिमेंट तो नहीं बदल रहे हैं. So I am just writing them down. 3 by 2 into 1 gives me 3 by 2 and 1 by 2. 3 by 2 plus 1 by 2 is 2. And see, P4, this element has become half of 4. So obviously, what will P40 be? These three elements remain unchanged. This element will be 20. And now I have to find the determinant of transpose of P40. So what is the transpose? And we know that the value of determinant doesn't change even if you take the transpose. So this becomes 1, 20, and this is 0 and 1. The determinant of P40 transpose is still equal to 1. I hope the solution is clear to all. All right. Let us solve one more question. Okay. Can you solve this one? If you know row operations, this is peanuts. All right. अब देखो row operations, it is not necessary to always add rows. You can also say that C1 can be replaced. The column 1 can be replaced by column 1 minus column 2 minus column 3. Correct? So I can replace this cosec square x minus cot square x minus 1. The second and the third column will remain the same. And here 40 and 2. Here I'll have cot square x minus cosec square x plus 1. And 42 minus 40 minus 2 is going to give me 0. So I have told you to evaluate a determinant. Either try to make one row or one column 0. If any row or any column becomes 0, all the three elements are 0 in any row or any one column, the value will be equal to 0. Now you know that cosec square x minus cot square x is 1. So 1 minus 1, the first element will be 0. So cot square x minus cosec square x will be minus 1. So minus 1 plus 1 will also become 0. So 3 elements in the first column become 0. अब कुछ करना ही नहीं है आपको, क्योंकि अगर 3 एलिमेंट 0 हो गए तो इसका मतलब क्या है कि इसका डिटर्मिनेंट 0 आने वाला है, आपको सोचना भी नहीं है. So the value of the determinant becomes 0. I hope this point is clear to all. Okay, so this is essentially a similar question to the one we have solved. Let us move on. These are all, you can just take screenshots and the answers are provided. Just do some row operations and you will be able to solve. Same thing over here. Just do some row operations. Take a screenshot, do row operations, and you should be able to solve. Now remember these properties. इसके ऊपर अभी last year या year before the last year IPMAT इंदौर में question आया था कि suppose मैंने आपको दे दिया determinant of A, एक मैट्रिक्स है A और इसके डिटर्मिनेंट की वैल्यू से 3 है, ठीक है, and A is a 3 cross 3 matrix. Now suppose I ask you what is the value of determinant of 4A. You can see that 4A is each element of the matrix is multiplied. So in order to calculate the determinant, it will be the same, and because it's a 3 cross 3 matrix, this 4 will be multiplied to each of the elements. So I'll take 4 outside, 4 cube multiplied by the determinant of A. I already have the value of determinant of A, so I'll get 4 cube, that is 64, multiplied by 3, that is 192. So this is how we have solved the question. So when I take out this scalar outside the matrix, I can't take out just 4. I will have to take out 4 to the power of n, where n is the order of the matrix. Please remember this. When I am calculating or evaluating the determinant, If it's a 3 cross 3 matrix, then when I take out 4, the scalar outside the matrix, I can't take 4. I have to take 4 to the power of n. In this case, I had to take 4 cube. So you have determinant of k times a as k to the power n into determinant of a. Determinant of a inverse is 1 upon determinant of a. And determinant of adjoint of a is determinant of a to the power of n by n minus 1, where n is the order of the matrix. So these are some properties which you should commit to memory. Okay. So I'll give you a couple of minutes, 1 minute to be precise. This question isn't worth more than 1 minute. इसी तरह का क्वेश्चन IIM इंदौर के एग्जाम में 1-2 साल पहले ही आया था. IPMAT IIM इंदौर में 1-2 साल पहले ही इसी तरह का क्वेश्चन आया था. ये इनफैक्ट बहुत ही आसान क्वेश्चन है. क्यों? क्योंकि हमें कैलकुलेट करना है डिटर्मिनेंट ऑफ AB into determinant of A transpose into determinant of B transpose. तो याद हमें ये रखना है कि determinant of AB is nothing but determinant of A multiplied by determinant of B, or determinant of A transpose is nothing but determinant of A, or determinant of B transpose is nothing but determinant of B. So what do you get? Determinant of A square into determinant of B square, which means be your answer. इसको मल्टीप्लाई करके जो भी आंसर आएगा वो आपका आंसर है. Next question. Try solving this. You can solve. 1 minute. ट्रिग्नोमेट्री के लिए 15 मिनट बचेंगे हमारे पास. उसमें हम सिर्फ 1-2 जो जिस पैटर्न पे क्वेश्चन आ रहे हैं उस तरह के क्वेश्चंस को हम सॉल्व करेंगे. 2-3 क्वेश्चंस एंड वी विल स्टॉप द सेशन देयर. इस तरह का क्वेश्चन मेरे ख्याल से पिछले 1-2 साल पहले ही आ चुका है, इसी तरह का क्वेश्चन. अब देखो, B is 2A. What does that mean? If B is 2A, the determinant of B. Now, one thing that has to be given here is ABC. A is a 2x2 matrix or 3x3 matrix. ये दिया होना चाहिए था, ये शायद मिस हो गया इस क्वेश्चन में. In any case, suppose A I take as 3x3 matrix, correct? Now B is equal to 2 times A. So what do you do? Cube out multiplied by determinant of A. So 8 into what is the value of determinant of A? 5. So 40. So determinant of B is 40. What about determinant of C? C is A inverse. So determinant of C must be 1 by determinant of A, that is 1 by 5. Now what is asked? The value of A, B, C, which means is equal to value of A individually, value of B multiplied by value of C. Value of A is 5, value of B is 40, value of C is 1 by 5. So your final answer is 40. This is a very easy question to solve. And you know, this was one of the questions which appeared in, this was similar to one of the questions that has appeared in IIM Indore IPMAT exam. So let us quickly go through the revision of trigonometry. Now remember 180 degree is equal to pi radians. So which means 90 degree will be pi by 2. 60 is 180 by 3. So I'll call it pi by 3. 45 is 180 by 4. So pi by 4. See, 180 degree is pi radians. So 90 will be 90 by 180 into pi. So pi by 2. That is how you convert degrees into radians. Since radians is one of the SI units, you should know how to calculate, how to convert from degrees to radians, because this is very common in trigonometry. Now, solve this particular question. 1 minute. Okay. So you're told that four angles of a quadrilateral PQRS are such that differences P minus Q, Q minus R, and R minus S is the same. It only means that PQRS are in AP. Correct? P, Q, R, and S are in AP. Why? Because there is a common difference between two succeeding terms. Right? So I can write the smallest as S or smallest as A. So I can write S as A, R as A plus D, Q as A plus 2D, and P as A plus 3D. Now we are told that smallest angle is half of the largest. So this is the smallest angle, A, which is half of A plus 3D. So if you solve this equation, you are going to get A is equal to 3D. This is your first equation. And because it's a quadrilateral, we know that the sum of these four angles will be 360. So A plus D, plus A plus 2D, plus A plus 3D must be equal to 360. And I can easily replace each of these A by 3D. So 3D, 3D plus D, 4D, 3D plus 2D, 5D, and 3D plus 3D, 6D is equal to 360 degrees. So 7, 5, 12, 6, 18D. So D is equal to 20 degrees. And we know that A is equal to 3 times D. So A is equal to 3 times 20. That is 60 degrees. But this is the smallest angle. I have to find the largest angle, which is A plus 3D. So 60 plus 3 into 20, that is 120 degrees. This is your answer. I hope you were able to understand this. Now you all know that sine of theta in a right angle triangle, if this is your theta, then this is opposite side represented by O. This is your adjacent sides represented by A, and this is hypotenuse. This is what our standard nomenclature is. So sine theta is OH. OH means O upon H, opposite upon hypotenuse. हम इसको generally perpendicular upon hypotenuse बोलते हैं, but the correct terminology should be it is opposite to theta and hence opposite upon hypotenuse. Cos theta, AH is adjacent upon hypotenuse, and tan theta is opposite upon adjacent. Now remember, 1 by sine theta is cosec theta, which is hypotenuse upon opposite. 1 by cos theta is sec theta, which is hypotenuse upon adjacent, and 1 by tan theta is cot theta, which is A upon O. So hopefully this definition is clear. More important is how to calculate different angles. Now remember, there are several ways to remember this: add sugar to coffee, all school to college, cast. Cast means you divide you divide the xy plane into 4 quadrants, 1, 2, 3, and 4 quadrants, right? In the first quadrant, all are positive. So A. In the second quadrant, sine and 1 upon sine, that is cosec, will be positive. The rest are negative. In the third quadrant, tan and cot are positive. The rest are negative. In the fourth quadrant, cos and sec theta are positive. The rest are negative. This is something which you need to know. So that is why CAST as a rule. Now remember, if I want to calculate any bigger angle, so I need to break that angle as sine n into pi by 2 plus theta, or plus or minus theta. If n is odd, then sine becomes cos, tan becomes cot, sec becomes cosec. If this n is even, then sine will remain sine, tan will remain tan, and sec will remain sec. Nothing will change, right? If n is odd, sine becomes cos and cos becomes sine. Tan becomes cot, cot becomes tan, sec becomes cosec, and cosec becomes sec. For example, if I were to calculate sine of, let's say random angle 750 degrees, correct? So 750 degrees, I can write this as 90 into, why 90? Because I have to see how many times 90 degrees or how many times pi by 2 plus theta 750 degree is. My first thing is I will change this into 90 into 8 plus 30. Just divide 750 by 90. What is the quotient? 8. What is the remainder? 30. So 90 into 8 plus 30. 8 plus 30. So which is nothing but sine of 8 pi by 2 plus 30. I told you if n is even, here n is equal to 8, then sine remains sine. That is the first way, first thing you keep in mind. The next thing you need to keep in mind is which quadrant are you working on. Now remember, on this, you will get 2 pi, 4 pi, right? 6 pi, and so on. Over here, you will get pi, 3 pi, 5 pi, and so on. Here, you are going to get pi by 2, 5 pi by 2, 9 pi by 2, and so on. Here, you are going to get 3 pi by 2, plus 4, 7 pi by 2, and so on. So remember, we have 8 pi by 2 plus 30. So pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2. So basically, you're going to complete 2 full circles. So you're back here. 8 pi by 2 means you're at 4 pi, you are on along the x-axis, plus 30. So this angle 750 is in first quadrant. See, pi by 2 once, 2, 3, 4, 5, 6, 7, 8. So you have reached 8 pi by 2 here. And 8 pi by 2 plus 30 will lie in the first quadrant, which means in the first quadrant, all are positive, so sine will be positive. And since n is even, sine will remain sine. So I will write this as sine of 30. That is how you change angles. Let us do a few more times. Okay. Let us say sine of 660 degrees. Now I will write this as sine 7 pi by 2 plus 30 degrees. So once again, let me see where do I reach. 1 pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2, 5, 6, 7. So this is the point of 7 pi by 2. If I do plus 30, that means I'm going to go into fourth quadrant. I'm going to go into fourth quadrant. In fourth quadrant, sign is negative. So I will take a minus. And since n is odd, sign will convert to cos. I'm going to get minus cos of theta, that is minus cos of 30. And what is cos of 30? Cos of 30 is root 3 by 2. So this will give me minus root 3 by 2. I hope you've understood how to find these bigger angles, right? Now try to solve this question. Now let's quickly solve these, or let me solve these questions for you. So tan pi by 11, tan 2 pi by 11. Now it's a good question. How to solve it? But I'll write this as tan pi by 11 plus I'll write this as tan 2 pi by 11 plus I'll write this as tan 4 pi by 11. Now remember, 7 pi by 11 is nothing but pi minus 4 pi by 11. See, 7 pi by 11. So I can write this as tan of pi minus 4 pi by 11. Similarly, I can write this as 9 pi by 11 as pi minus 2 pi by 11. And similarly, I can write 10 pi by 11 as pi minus pi by 11. Now, if you look at this is pi by 2, this is pi. So anything that is pi minus something has to be in the second quadrant, and in this tan is negative. And since it is pi, I can write this as tan of 2 times pi by 2 minus 4 pi by 11 plus tan of 2 into pi by 2 minus 2 pi by 11. That is how we'll write it. And plus tan of 2 into pi by 2 minus pi by 11. That's how we will write. I have not changed these three terms. I am only making an alteration to the second, third, fourth, fifth, sixth terms. Now here n is positive, sorry, n is even. So tan will remain tan. But 2 pi by 2 is here, and 2 pi by 2 minus 4 pi by 11 is in the second quadrant where tan is negative. And it will give me minus tan 4 pi by 11. By the same logic, here I'll get minus tan 2 pi by 11. And by the same logic here, I will get minus tan pi by 11. And here you have tan pi by 11 plus tan 2 pi by 11 plus tan 4 pi by 11. सब कट जाएगा आपस में. And you are going to get a big zero. Have you understood this? If you understood, give me a thumbs up, please. If you understood this, please give me a thumbs up. Yeah. Now, I wanted to take a screenshot of this question. Okay, let us solve this also. And this will be the last question that I solved today. Sine 430 can be written as sine of 360 plus 60. Cos 390 can be written as cos of 360 plus 30. Plus cos of 300 can be written as 360 minus 60. And minus sine 360 minus 30. This is how you have written this. Now 360, what is it? 8 into pi by 2 plus 60 degrees. So if you look at the quadrant, where is 8 pi by 2? This is pi by 2. This is pi. This point is 3 pi by 2. This point is 4 pi by 2. 5, 6 pi by 2, 7 pi by 2, and 8 pi by 2. So this line is 8 pi by 2, and plus something will give me an angle in the first quadrant itself. In the first quadrant, everything is positive. So I don't need to worry. And because this is 8, it is even. So I will get a sine 60 degree here. Similarly, cos 4 pi by 2 plus 30, what will it become? It will be in the first quadrant itself. And since it is in the first quadrant itself, I am going to get cos 30 because in the first quadrant, everything is positive. Sine, cos, everything is positive. So what will I get? And this is 4 pi by 2, so 4 is even. So cos will remain cos, so cos 30 plus cos of 360 minus 60. Now this is cos of 8 into pi by 2. And this also should be 8 minus 60. Now mind you, 8 pi by 2 minus 60 will be in the fourth quadrant and cos is positive in this quadrant. And since it is n is even, cos will remain cos. So I can write this as cos of 60 degree multiplied by, in this particular case, sine of 360 minus 30 will be minus sine 30. So minus into minus plus. So I'll get plus sine 30. So what do you get? Sine 60 is root 3 by 2. Cos 30 is also root 3 by 2. Cos 60 is 1 by 2. And sine 30 is also 1 by 2. So 3 by 4 plus 1 by 4 is equal to 1. So I guess I'll have to end the session here. I hope these sessions, if you've not seen the previous session, please go to our channel Pathfinder for me and have a look at that session also. These questions are very similar and on the same difficulty level as the questions that have been asked in IPMAT of IIM Indore. Try to solve these questions and we hope you do well. That's all for me. All the best to all of you for IPMAT, both for IIM Indore also and for JIPMAT. Thank you very much.